Okay, so this next lesson is on verifying inverses, and what we know about inverses is graphically, if you have a graph, and let's say we've got something that looks like I don't know, we'll just say looks like this, goes this way, and it goes this way. If we have an inverse function, right, I know that that is a reflection over the line y equals x. So if that's the line y equals x, then your inverse function is going to look something, like it's going to go, kind of like this and sort of like this, and then it's going to look like a reflection of this over this line. So if you took it and you kind of turned it, flipped it, that's what it would look like. So algebraically, there's a way to prove if functions are inverses of each other using function composition, and that's sort of what we're going to do today. And not sort of, it is what we're going to do today. And we will, there's a real clear way to do it. It's not super complicated. It involves obviously being able to know a few things about working with algebraic equations, but nothing that you haven't worked with and haven't done before. So we're going to just put it all together today. Okay, so we're going to be able to prove whether two functions are inverses of each other, including one or two functions inverses, and then proving that they are or aren't. Okay, so here is the idea. So what it says up here is two functions, f and g, are inverse functions if and only if both of their compositions are the identity function. So what they mean by that, right, is the identity function in this case is this y equals x, right? This y equals x function is what we're after, right? And so what we have to be able to do is we have to be able to prove this going both ways. So we would do this first function composition, right, which means we take g of x and then we would put it into f for its x and then see if we get something that looks like this. And then we would turn around and we would do the same thing the opposite way, taking f of x and putting it into g and seeing if we get that same thing. Right, and so we have this little strategy written down here, and what it says is if the first one, if f of g of x simplifies x, that means that you've got at least one out of two, so you're going to keep going. Now, if you know right away that it doesn't work, then you know that these functions aren't inverses. It has to work right away. And if it doesn't work and doesn't give you something like this, then you stop, right? But if it does work, then you keep going, all right? And then you're going to do your g of f of x, and if that one simplifies to x, the functions are inverse, and if that one doesn't, then they're not. So you have to bat 1,000 on this. You gotta get 2 out of 2 and make sure they both will get you to this, all right? So I think the best thing is just to kind of do some of these for you and talk through it. All right, so this is my f function, this is my g function. So the first one we're going to do is we're going to do f of g of x. All right, and so I'm going to use the same technique I've always used. All right, so the first thing I'm going to do is I'm going to find g of x. All right, my g of x is just this, right? It's 1/3 x minus 3. And so now I'm going to take this and I'm going to plug it into f of x wherever I see x. So I'm going to go f of x is equal to 3. I'm going to put a nice big parentheses wherever I see the x, and then plus 9. So this is my f of x function, and now I'm going to take this and we're going to plug it in there. So we're going to go 1/3 x minus 3. Okay, and so now we got to multiply this by both of these things. So 3 times 1/3, right? Your fractions cancel. Okay, so you get x, and then 3 times -3 is -9, and then plus 9. We're going to change this f of x into y, all right? And then we have -9 and +9. My next step are going to cancel each other out. So we are going to wind up with y equals x. So we're halfway there. So we've got that, right? So we are going to keep going, okay? Because we got the first one. And so now the first one, or the second one, we are going to work the other way, right? So we're going to start with f of x. All right, so my f of x is this 3x plus 9. Okay, and so now when I figure out what g of f of x is, right, so I should have written this as f of g of x. All right, so g of f of x, I'm going to write this like 1/3. I'm going to leave a spot for x minus 3. And in that spot, I'm going to plug in my f of x, so 3x plus 9. All right, and so 1/3 times 3 gives you 1 again, just like it did over here, right? These cancel. And then 1/3 times 9 is, well, if you have 1/3 times 9, right? You can, 3 goes into 9 3 times. 3 goes into itself once. So you get 3 over 1, which is 3, right? So you get plus 3 minus 3. We're going to change this into our new y. And then y equals x because your 3's cancel. And so we got it both ways. All right? So we would say they are inverses of each other. Okay? And that's the technique. That's how we're going to do this. All right, so I'm going to stop the vid here, and then in the second and last, or second out of probably 3, I'll probably do one with a homework problem or 2. I will go over a couple more of these.